And Popper provides a few examples. He says, the logical positivist criterion of meaning or of demarcation is too large and too narrow at the same time. Too large, meaning that it includes within the realm of science elements or theories which we might want to exclude from the realm of science. Whereas on the other hand, it excludes elements or theories which we want to include in the realm of science. Let us provide a couple of examples. Take the famous case of astrology, which was regarded as a proper science during the first scientific revolution. For example, Galileo himself, Kepler, Tycho Brahe, all the main characters in the scientific revolutions were all practicing astrologers to a higher or level or lesser degree. Anyway, we read astrological forecasts, so maybe we don't, but anyway, we know that there are astrological forecasts published in newspapers every day. Let us assume that astrology is a theory. It makes predictions. These predictions are usually quite vague, quite general, and so their probability of being confirmed in experience, supported by experience, the probability that they actually predict something and this something actually happens, takes place, is not bad. And indeed, it seems if we read horoscopes, everyday horoscopes, that they are to some extent correct. They actually predict what then actually happens. So according to the logical positivist criterion of demarcation, that is verification, they are verified, they are confirmed by experience. And therefore, they should be deemed scientific. In this sense, the logical positivist criterion of demarcation is too large. It ends up including in the realm of science elements which we know do not belong to science. On the other hand, the criterion of demarcation advanced by logical positivists is too narrow. That is, it excludes things we might want to include. For example, take universal laws, such as Newton's universal law of gravitation, or the second principle of dynamics, F equals m times A. Force is equal, well, I don't have to tell you about that. Anyway, these two laws are scientific laws, which are by definition universal laws. That means that these laws are valid anywhere in the universe, according to Newton, on the Earth and all other planets, even if we've never been, and Newton has never been onto any other planet. He's not been, not even outside Europe or outside his own country. So how can he come up with a universal law, a very general law? Of course, he devised this law and claimed it was general, so that it is a law valid in each and every case, of which we have had experience and of which we have not yet had experience. So as such, a universal law cannot be verified, because it refers to an infinite number of cases. And so it cannot be verified according to the principle of demarcation, therefore, of the logical positivists. Therefore, according to the criterion of verification, universal laws such as Newton's law of gravitation is not part of science. That is why not only verification is wrong, but it does not do what it is supposed to do. How did Popper come up with this criterion of falsification? According to his own autobiography, he attended a lecture given by Albert Einstein in Vienna in 1919. As you know, 1919 is the year in which the general theory of relativity was confirmed by experimental results. The Royal Society expedition led by Arthur Stanley Eddington actually corroborated in Popper's terms or provided positive evidence for the general theory of relativity. And so Einstein became quite famous, and he was the one who actually tore the statue of Newton down. He took Newton's down from the pedestal on which it was set in the 17th century. Anyway, so he started giving a number of lectures. Einstein started giving a number of lectures, and in Europe, and he gave one in Vienna. Popper attended that lecture, and he claimed that listening to Einstein, he saw the difference between Einstein's theory, which was a scientific theory, and other theories he was dealing with at the time, namely Marxism and Adler's individual psychology, which is a variant of Freud's psychoanalysis. Popper said, I understood the difference between these two kinds of theories. One is scientific and one is not, and the others are not. And I saw what differentiates, what characterizes, what is the scientific character of one and which is absent from the others. Namely, Einstein's theory was risky. It made a prediction about the deflection of the rays of light coming from the sun when passing by a massive object in the sky. The deflection was predicted to be of a certain, how can I say, angle. And this angle was actually passed the test, the experimental test. Observations actually supported Einstein's prediction, or confirmed or corroborated, in Popper's terms, Einstein's prediction. But it was a risky prediction. Einstein did not say the deflection will be of any angle between 0 degrees and 360 degrees. In this case, the theory would have been, if the prediction was between 0 degrees and 360 degrees, the prediction would have been 100% correct. So the theory would have passed the test, but it was not a risky prediction. It was a risky prediction because it ran the risk of being falsified or being refuted by experience. If it said between 0 and 360 degrees, it was impossible for it to be refuted. So Popper said, when a prediction is risky, it may be refuted. If it's not risky, it cannot be refuted. So the scientific character of a theory is it's being risky. It's being liable to be refuted, to be falsified. As opposed to Marx's theory, for example. Marx's theory, which Popper he said of himself that he was a Marxist at the time. Marx's theory started off as a scientific theory. Marx made a number of predictions about society. Then this theory, these predictions actually, turned out to be refuted. They did not happen. They did not take place. So Marx's theory started off as scientific in Popper's eyes, but then later on, when his predictions were not, when the theory did not pass the test of history, so to say, Marx's followers changed or slightly changed the theory so as to cope with these falsifications, so as to cope with these refutations, saying, well, yes, it was not exactly how Marx predicted, but we can slightly modify the theories so as to avoid this falsification. And this, according to Popper, is a mistake, because a theory is scientific if it can be refuted by experience. And the content of a theory, what a theory tells us about the world or about society, about whatever is its content or its aim, the content of the theory is whatever the theory forbids. The content of a theory is the class, Popper says, of its potential falsifiers. If we, in front of a falsification, decide to prevent the theory from being falsified, we lower the number of potential falsifiers for the theory. We lower the number of possibilities of it being subjected to reality, to a test, and not passing the test. And therefore, we lower the content of the theory. The more a theory says, the more it forbids. If it does not forbid anything, it does not say anything. And that's a crucial point. So Marx's theory started off as a scientific theory, but was later turned into a non-scientific theory because Marxists kept changing it, according to Popper, thereby lowering until zero the content, the class of its potential falsifiers. On the other hand, Freud's theory or Adler's individual psychology were not scientific from the very beginning, because these theories are able to account for any phenomenon in the world. Any phenomenon can be properly explained or accounted for by Freud's theory, by Freud's psychoanalysis and its variants, of course. So Popper says, being able to account for any possible outcome is not a virtue of the theory. On the contrary, it is a vice of the theory. Because being able to account for any possible outcome means that the theory cannot be falsified. So to put it again in Popper's own terminology, if the more a theory says, the more it forbids. The content of a theory is the class of its potential falsifiers. Or to use another quote from one of his pupils, if we have a theory, we subject it to a test, and the theory passes the test, so it's not falsified, we know something, he says, because we know that what we knew before the test, our theory is still there, but we've learned nothing. On the other hand, if we have a theory, we test it, and the theory does not pass the test, we know nothing, because what we knew before the test, we no longer know because the theory is gone, because it's been falsified, but we've learned something. Namely, we've learned that what we thought we knew is no longer the case.